maybe 50 years, 100 years, or 200 years from now, people will look back and say, how could we have ever thought that there was nothing but matter and energy in time and space?
Keep watching to learn more.
Book 3 in the New Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we are going to explore the double-slit delayed choice experiment in physics. With me is physicist Dr. Edward Close, who is the author of Transcendental Physics. He is also co-author with Vernon Neppe, who has been a guest on this channel many times, of a book called Reality Begins with Consciousness. And most recently, he is the author of a lengthy chapter in a new anthology titled Is Consciousness Primary?, edited by Gary Schwartz and Marjorie Woollacott. Marjorie has been a guest on this channel. And the title of his chapter is called The Mathematical Unification of Space, Time, Matter, Energy, and Consciousness. Welcome, Ed.
I'm very honored to be here, Jeff. I've admired your work in Thinking Aloud for years, and it's a privilege to be here and a pleasure to meet you.
Well, it's a pleasure to be with you. And, I know I have, and I'm sure many of our viewers have heard of the double-slit experiment and the double-slit delayed choice experiment, but probably very few people understand the details and the significance of this experiment. But it's kind of crucial for understanding the relationship of consciousness in the physical world, wouldn't you say?
Yes, very definitely. It was a key element in the development of ideas for me. Well, maybe we should talk a slight bit about the double-slit experiment. That was an old experiment that was actually performed first by a British medical doctor, an MD, who thought he had disproved Isaac Newton's theory of corpuscles, which is Newton's word. We now call them photons. That light traveled in little packets or little blobs called corpuscles through the ether. And so he thought he had disproved that because when he took 2 slits and put light through them, the light on a screen on the other side broke up into bands like waves in the water would. Mm-hmm. Like if you put something fluid through both of these, then when they came out, they created waves that both interfered and alternately interfered and added to them together, created these bright bands.
An interference pattern.
Yeah. And there it was. So, a light's a wave function. Light is a wave phenomena. So later on, of course, we found out that it could be either one, depending on the choice made by the experimenter. This was the first inkling that the consciousness of the human being, the sentient being, conscious being within that framework actually made a difference that made decisions that conscious being made a difference in the way that something as basic as light could actually manifest in reality.
So there was this dispute already. If you set up the experiment one way, you get wave phenomenon. You set up the experiment a little bit differently without the double slit, I guess,
yes.
And then it looks like particles.
Yeah, it's a scattergram. There are no waves. It's like little particles. But so that was kind of the beginning of
So this was known even before quantum physics, I guess.
Yes, it was. It was even before the whole idea of electrons even existed in science. So that came up a little later.
Yeah. So very early on, there was this paradox, like light sometimes behaves as if it's particles and sometimes as if it's waves.
Yeah.
That must have been very troubling.
Now, yeah, Dr. Young didn't get to that. To him, it was wave phenomena, end of story.
Yeah.
Newton's idea of corpuscles was wrong. But then later, other physicists came along, and as physicists do, analyzed it further and further and said, well, look, if we open up just one slit, we close the other one off, then we get a scattergram just exactly as if these were traveling as little miniature baseballs, little objects, and splattering onto the screen on the other side. So that was a paradox there. I like to say physicists were in trouble as far back as then. They just didn't know it yet, as far as matter-mind question.
Yeah. So this is all long before Einstein formulated with Rosen and Podolsky the EPR paradox.
Yes.
Well, many of our viewers will have heard all about the EPR paradox for years. I first wrote about it in 1975 in my book, The Roots of Consciousness, but I'm sure many of our viewers don't know what it is. So why don't we start there? Let's define that.
Sure. Albert Einstein, who was my idol when I was young, and still is, was not comfortable with quantum physics as it was being carried out by, basically at that time, Bohr and Heisenberg, taking off from the discovery by Max Planck that energy and matter are quantized in the world. The thing that they came up with is that at the quantum level, there's a intrinsic uncertainty there that if you, as we try to do in physics, nail down exactly the location of something, you could not at the same time get the exact energy or action of it in terms of say, rotational motion and things like that. So, or vice versa. If you pin down the angular momentum and put a number on that, the exact location became blurry. Einstein said, uncertainty is not something we're striving for in physics. We're always striving for exact numbers and certainty, things we can hang our hats on. So I think quantum physics is incomplete as exists. And so he had a problem with that uncertainty element, the Heisenberg uncertainty principle, it's called. And so he and his group of two other physicists, friends of his, Podolsky and Rosen, came up with what appeared to be a contradiction of the uncertainty principle. And that was a problem for the quantum physicists because they'd already found that by looking at it that way, we developed a lot of the electronic gadgetry we have now based on that factor. And if it was in fact untrue, then how could all this technical equipment work if it was untrue? So
you're talking about computers and cell phones.
Yes, all the things we take for granted today that work on the principle of electronic field theory and so forth. And so anyway, they came up with what was essentially looking at subatomic particles like an electron or a photon, and looking at a situation where if you had a subatomic reaction that created two particles that were like reflections of each other, because in physics there's symmetry and asymmetry. And symmetry in a symmetric situation, if two particles are created and one's spinning one way, the other one is spinning the other way, and the two together are balanced. So that's a symmetry that's going on there. And they reasoned that you could actually take the exact location of one of these and from that predict through symmetry what would be the angular momentum of the other particle, and you would have you've done an end run around the uncertainty principle. You've given, for a given particle, then, both of those bits of information that supposedly could not be obtained exactly. Mm-hmm. So, for a while, Niels Bohr and Werner Heisenberg were kind of stumped by this. But then
if I may interrupt, this was Einstein's way of trying to disprove quantum theory.
It was.
He called it spooky action at a distance, some sort of instantaneous information transfer faster than the speed of light that shouldn't occur.
Yes, should not occur. And so therefore, if you took what we know about the mechanics of subatomic particles and certain reactions that have been studied extensively, that you could actually discount or disprove, really, the uncertainty principle.
Yep.
So the answer was a remarkable thing that put particle physics and quantum mechanics off on a different track altogether, because what Bohr eventually said was there's no way of knowing that those are the same particles just because you've done this thing. Actually, they don't exist as particles until they're actually measured at the end, and this was called the Copenhagen interpretation. Mm-hmm. And there have been various things done with that. But
the Copenhagen interpretation, because Niels Bohr was in Copenhagen.
Yes, that's the reason that term was used. That was his basis of operation. He was Danish.
Yeah.
And anyway, so that was the EPR paradox. The paradox was, if quantum physics is the uncertainty principle is right, then we've just shown that there's a paradox, because particle physics says, no, we can do this. We can find this information by a simple experiment like this. But then, of course, Bohr came back, and that was the beginning. And that was an important part that led up then to what we're going to talk about.
The double-slit delayed choice experiment.
Yeah, our paradox then inspired John Wheeler, who was had been a student of Einstein at Princeton, to think about this on a deeper level. And if you've seen the presentations by Fred Alan Wolf, calls himself Dr. Quantum.
Fred is a dear friend of mine, and has been on this channel many times.
I met him several times at conferences, and we've talked a lot. And I love him because he's older than I am, and I like to see that's encouraging when I see people who are older yet than I am. And at any rate, he talks about the fact that if we try to see that electron or particle, whatever, as it's traveling through and beyond these two slits to get to the screen, the more we try to look at it is what causes it to change. Mm-hmm. And Dr. Wheeler brought in the idea, he called it from bit, that bits of reality become something because they're being observed. Mm-hmm. And he reasoned that if this is true, and if even some interpretation of the Copenhagen interpretation, because there's been a lot of discussion about that among physicists, especially the physicalists or materialists among them, who think there's nothing but matter and energy interacting in time and space, mm-hmm. and discount anything else as secondary.
Well, let me interrupt for a moment. When you say Wheeler came up with the notion of it from bit, yes. If I understand it correctly, and correct me if I'm wrong, the bit refers to bits of information, as in a computer, yes. and the it refers to something physical and solid. So exactly. Wheeler is saying that information exists prior to physical reality. Isn't that what he means?
Yes, that's certainly one way of saying it. I think that's an accurate way of saying it. And so he reasoned that if this is true, this is really the reality we're dealing with, then any time you make the decision to open or close one of the slits, doesn't matter if it's before if you're thinking in terms of photons, if it's before the photons or the wave gets there or after, it won't matter because it isn't a thing until it hits the receptor of the screen on the other side. So he reasoned that I can, physicists like to get down to very small times and spaces, and he said, I can actually set this up. Maybe I'll have to have a bigger laboratory, but this could be set up so that we can test this and see, because what it means is I can make my decision after theoretically that photon is already past the slits, and it will still give me, depending on the decision I make, either interference patterns mm-hmm. or a scattergram, depending on the decision I make.
In other words, not depending upon how many slits are available.
Right.
But depending on the conscious decision made by the observer.
Yes, exactly.
Because you have to be awful quick because light travels so fast
yes.
to actually make the decision after the light has passed through the slit or slits.
Yes.
But before it hits the receptacle where a measurement is made.
Yes, he even envisioned this on a cosmological scale, but that's another story. I won't go into the details of that. We might get to it later.
Yeah.
But this whole thing is the basis for the double-slit delayed choice experiment, because you're delaying your choice of whether it's going to be two slits or one until after the energy supposedly has already passed the slits.
Mm-hmm. Well, I like the idea of doing it in a cosmological space because, a beam of light takes a easily measurable length of time just to go from the Earth to the moon.
Yeah.
A few seconds at least.
Yes. Yeah, and so that's like a bigger laboratory. Like I was saying, I might have to expand the laboratory. And of course, Wheeler himself didn't actually do the experiment. This is kind of like the EPR thing. The experiments weren't done that proved who was right, Bohr or Einstein, until after Einstein had passed away. But and then the technology caught up with the theoretical physics, and this was the same way. Mm-hmm. The technology didn't catch up for a few years, but when it did, there was an experiment performed in Germany and one in the United States at about the same time by different teams of physicists.
And when would this have taken place?
Probably in for the delayed choice, it's probably in maybe the 60s, the 1960s, somewhere in that range. Mm-hmm. Certainly later than 40 and earlier than the 70s, I think, in that time frame somewhere. And both of them showed that this concept was correct, that what Wheeler had intuited actually worked, that in fact you could make the decision after, whether you're thinking of light as waves or particles, either one, takes choice, it's still, you could make the decision after waves or particles had theoretically passed the two slits.
Yeah.
And it would still have the same effect, whether it would manifest as waves or particles.
In other words, to be clear, let's suppose you have two slits. So theoretically, based on earlier work, you're expecting the pattern to show up as an interference pattern, indicating that light has wave-like qualities.
If there are two slits.
If there were two slits. But then you make a decision after some light has passed through the two slits that I really want just one slit. And the lights that have already passed through two slits are now going to behave as if there was only one slit.
Yeah. Now, what does this tell us? It goes back to what your friend, Michael Talbot said.
Michael Talbot is the late Michael Talbot, author of The Holographic Universe, was a friend of mine, yeah.
Yes, he made the statement that this tells us that space and time, and maybe even matter and energy, are not what we think it is. It either is something different, or there's something going on here that can't be explained by classical physics or by our macro-level understanding of reality. Yeah. There's something going on that will change fundamentally our understanding of space, time, matter, and energy.
Because I think it's true to say that most people have such an instinctive awareness of space and time as sort of the matrix within which we exist that we never question it.
Yes, because that's what we think we experience. But this is telling us that something different is actually going on. That space and time, and this brings up that one of the last things that Albert Einstein wrote, his wonderful little book called Relativity, the Special Theory and the General Theory, so that anyone can understand it. That was the title of his book. Anyone can understand. He discussed this, and he wrote an appendix to it just a few years before he passed away, in which he addressed the problem of space. This is the way it started. But by the time you read the appendix, he's talking about space-time, or the combination of time and space, which I call variables of extent.
Mm-hmm.
And that they actually have no existence of their own. So, contrary to our sort of normal thinking that space and time is things that exist, as you said, in which things happen, the matrix or the environment or the field or whatever within which something happens, isn't really the case at all. That the space and time are things that only exist because of the interaction of mind and matter in the decisions and the distinctions that we make. And I know we're going to talk more about that.
In other words, most people sort of think space and time are primary. That's everything exists within space and time. And what you're saying is, no, space and time are secondary to matter, energy, and consciousness.
And this is what Albert Einstein said in his little appendix. He said, space and time have no existence of their own. They claim no existence of their own.
Mm-hmm.
They only exist because of... Another way to put it that I think might help is an event is a space-time matter-energy thing that happens. Just like us talking, we're talking together we can call this an event. Well, events seem to happen in time. But if you have no events, do you still have time? And he's saying no. There's no such thing as time without events. There's no such thing as space without distinctions, without matter and energy.
Mm-hmm.
So the quantum field theory comes closest to explaining this, and that gets into the whole idea of is there something or isn't there something, of Leibniz's question. But the whole thing of whether space and time exist, they don't if you don't have matter and energy and events going on.
I know you draw from this a very important point, which is since quantum physics is well established now, that matter and energy exist in quanta. They can't go any smaller than the quanta. So you're saying that therefore space and time must also be quantized.
Yes, this is a difficult, subtle distinction, and you can look at it one way. If you take Einstein's view that they have no existence of their own, then obviously you can't divide something that doesn't exist. So, but if you're going to talk about space and time, and if you're saying they are secondary to matter and energy are quantized, then the only space and time that will matter in your mathematical description are quantized bits of space and time. So in that sense, it only makes sense if you think of quantized space and time in conjunction with quantized matter and energy. And I make the distinction in Transcendental Physics, and Dr. Neppe and I have made this distinction in our TDVP model, that there are variables of extent, that's various kinds of dimensions of space and of time and of consciousness. And there are variables of content like matter and energy and concepts in consciousness.
Now, you mentioned your TDVP model, and I know for viewers who have watched the many interviews with Vernon Neppe, they'll know what we're talking about, but I guess at least we should tell people what TDVP stands for.
Yes. So it stands for triadic vortical. Vortical meaning, vortical's the adjective for the idea, for the noun vortex. Triadic, vortical, dimensional, because it turns out that in developing a quantum mathematics, dimensions and extent are extremely important. Paradigm. And we use the word paradigm in the same sense that Thomas Kuhn did in his book about revolutions of science. The idea of a paradigm, now, the word is, in my opinion, totally overused today. People will say, well, I don't think in terms of that paradigm, meaning I have a different mindset. But paradigm, as we're using it, and as I believe Thomas Kuhn meant it to be used, is an underlying metaphysical, if you will, understanding of what's behind reality. It's the framework within which we put all of our thinking and our thoughts. A paradigm shift means some radical change in that by bringing in maybe a new a priori assumption. And this could lead to talking about logical systems and how they work and don't work, and a whole host of very interesting things. But the paradigm, then, in my opinion, there's not been a paradigm shift in science since relativity and quantum physics. All of it's what's been going on since then, as Kuhn describes that too. That's what what engineers and technicians do. They fill in the dots. The
normal science.
Yes, normal science is filling out the details of the paradigm. Now I've had physicists argue with me and say, well, you're just discounting all the wonderful discoveries in particle physics, the Higgs boson and all of these things that are really very important, and there were big breakthroughs. Those were paradigm. No, they weren't paradigm shifts. They were figuring out details that fit within the paradigm shift that happened between 1900 and 1930 or 35.
But I think it's fair to say, and why we titled this program the Double-Slit Delayed Choice Experiment is because that experiment really highlights the urgent need to think in terms of a new paradigm. The idea being that the consciousness of the observer is having a direct impact on the experimental results would seem antithetical to a kind of physics that only talks about matter, energy, space, and time and has no room for consciousness.
Yes, you put it perfectly. That's exactly what the paradigm shift is. We see TDVP as a shift from a materialistic-based paradigm to a paradigm that is broader in the sense that it can contain scientifically consciousness and aspects of consciousness in the same way that it contains or studies or analyzes realities of matter and energy in space and time.
Now, I'm under the impression that the Copenhagen interpretation, which basically, if I understand it correctly, it is that it is the consciousness of the observer that calls forth the observed result. That by and large, the physics community, because of their habitual inclination toward metaphysical materialism, has tended to reject the Copenhagen interpretation. And Wheeler, for example, brought forth an alternative known as the multiple worlds interpretation.
Yeah, I was thinking of something that he said, and he wrote a wonderful book called At Home in the Universe. And I love that title because we realize we're part of it. And that's the big change in yesteryear's natural science. The consciousness was not a part of the reality we're studying. That was actually a definition of objectivity. Mm-hmm. You keep consciousness out of it, and you're studying in an objective manner. I remember writing in my book Transcendental Physics, and however long ago that's been, 20-some years, that we need to revisit and rethink about the term objectivity, because we need to become objective about, there needs to be a conscious inner objectivity as well as an outer objectivity. Mm-hmm. And that's what a shift to a consciousness-based science does. It expands science so that it is more comprehensive and can include conscious phenomena or even spiritual phenomena that are off limits to contemporary science.
Would you say that the multiple worlds interpretation is a way to eliminate consciousness from the picture? Is that Wheeler's intention?
A lot of the things that physicists have done are because they find it so disconcerting or so distasteful to start talking about these fuzzy, weird, what they consider secondary things like mind, well, not mind particularly, but the actions and the consciousness.
Because they view consciousness as an epiphenomenon, something that is created by the physical brain, and therefore not even causal.
And that is what we've exactly reversed. That is why the biggest publication that Dr. Neppe and I have done is called Reality Begins with Consciousness. That gives some physicists apoplexy right off the bat because they say this is paradoxical, it's ridiculous. How can reality begin with consciousness? There was consciousness a long time before, there was reality a long time before there was such a thing as consciousness. Well, they're thinking of consciousness in a very limited manner as human consciousness.
Or biological
consciousness.
Yeah.
What we're saying is no, consciousness is fundamental And in my opinion, and a growing number of scientists now, consciousness is primary, not just fundamental, but it's at least as fundamental as matter and energy. And that's completely reversing it. That's saying that, as actually Max Planck said, and this is interesting, that physicists who base their whole paradigm on the discoveries of Newton and Einstein and Planck have ignored some of the things that Einstein and Planck said. Namely, when Planck said, as someone who has studied the hard science of matter my entire life, I can tell you this much. There's no such thing. There's no matter as such. Matter actually exists by the balance of energies that must originate in a mind that is transcendental to all of this. He didn't use that word. That's my word. But that's basically what he said over 100 years ago. And they don't like that if you're a physicalist. If your metaphysical base says everything that's real has to be matter, energy, space, and time, and these other things are epiphenomenal or secondary coming out of that. We're saying just the opposite. We're saying there was a form of consciousness, call it primary consciousness, that had to exist, and we can get into that when we talk about another subject, that had to exist prior to the time there could be any manifestation of particles or atoms or anything of this nature. It had to be there in order for there to be the stability that would allow things to be built up into the complex universe of organic organisms like you and me, and these roses here that exist now. Unless you reverse that, and that's the paradigm shift, then you'll never understand these other things because you'll always think they're not real. Mm-hmm. They're secondary, and we're saying just the opposite.
Mm-hmm. And the idea of a paradigm is such so that if you're kind of indoctrinated or wedded to a materialistic paradigm, this idea that consciousness is primary seems absurd. And yes. I think for people probably such as you and me, who are deeply imbued with an awareness of the power of consciousness, the idea that consciousness is an acausal epiphenomenon that doesn't really influence anything in the physical world, because how can it? It's not physical. That also seems absurd.
Yes, because in the final analysis, if you broaden your scope of thinking, the part that is matter, energy, space, and time is a very small part of the reality that we experience. And scientists like Niels Bohr have said, the business of science, and he was talking in the framework of science of his time, is not to explain the nature of reality, but is to explain what we can say about what we experience. If we don't experience it, we really can't say anything about it, like Wittgenstein's famous statement, that about which we cannot speak, we must remain silent. But we're getting to the point where we have to start thinking about, so we can speak about things that have been considered unscientific in the past. That's the paradigm shift. We want to be able to address those things in a scientific manner. And this is the only way we will get acceptance of the paradigm shift. And as you said, there is a great resistance to that because there are people who have worked their entire lives on the basis of a materialistic paradigm. And even if those people profess to be spiritually minded, let's say they are practitioners of a given faith or religion, they separate the two completely. early on, even when I was a child, I remember thinking, if this stuff is real, meaning science, or meaning religion, if religion and philosophy are actually real things, then they should be a part of our life all the time, not just on Saturday or Sunday or Friday if you're an Islamic follower. If it's real, then it's got to be a part of life every day, just like breathing or just like thinking. So I've always felt that we needed to expand the scope of science. And a scientist should be open to this, because scientists should be open-minded to the extent of realizing that anything we can experience, we should be able to address scientifically.
Well, scientists are human.
Yes.
First and foremost.
Yes.
In spite of their efforts to sort of transcend their own humanity. I mean, it was Max Planck, I believe, who said that science advances funeral by funeral.
Funeral by funeral, yes, he did, because he said, you're wedded to the paradigm in which you've existed and in which you have believed your entire life. And it needs to be somebody new that comes along and says, wait a minute, there's a different way we can look at this. And so from funeral to funeral. And that's unfortunate because it means, well, I would argue that relativity and quantum physics still are not understood even by most physicists. While the discoveries were made in the early 1900s, in the early 20th century, from about 1900 to 1935, in that period of time, these things were understood by people like Planck and Einstein, but only kind of rough analogies and concepts of it bled through to other physicists, other scientists even, and eventually to the man on the street. And even today, I find, in my opinion, that many very intelligent people, engineers, particularly people who follow the Aristotelian order of practicality, that mathematics is something to solve problems, look at this and still don't really understand the implications of the constancy of speed of light, for example. Mm-hmm. How that changes reality in a very fundamental way. That is, once you understand that, it's like a door's been opened. And I believe the TDVP is such a door. That as people see that this opens the door to a scientific understanding of consciousness and the actions of consciousness, then maybe 50 years, 100 years, or 200 years from now, people will look back and say, how could we have ever thought that there was nothing but matter and energy in time and space?
Well, Dr. Edward Close, what a pleasure to have this conversation. And I know you've raised probably many more questions than we've been able to answer here. In fact, we're mostly asking questions and not providing answers. But fortunately, you've come to Albuquerque, and we're going to have several more interviews while you're here. So we'll get into greater depth on many of these other questions. Thank you so much for being with me.
I can't wait. Thank you for having me here. I appreciate it very much.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.